Dear students, so today let us we study about the topic quantum numbers. In the earlier class, we have studied the significance of psi and psi square. You know, psi is nothing but it is a wave function which gives the amplitude of the wave, which is not having much significance, and psi square gives the probability of finding the electron more, which gives an idea about the orbitals. Now, to know about these aspects, a simple numbers are used in the wave mechanical theory, and this we call it as quantum numbers. The word quantum is used to all the energy levels available to an electron which are governed by the laws of quantum mechanics. In quantum mechanics, quantum numbers are used to describe the distribution of electrons in an atom. From the solutions of Schrödinger equation, three quantum numbers, namely principal quantum number, azimuthal quantum number, and magnetic quantum number are derived. The fourth quantum number, called the spin quantum number, arises from the spectral evidence. Quantum numbers are the simple numbers used to describe four properties of an electron, namely location, energy, shape of an electron cloud, and direction of spinning. There are four quantum numbers known as principal quantum number n, azimuthal quantum number L, magnetic quantum number m, and fourth spin quantum number s. Coming to the first one, principal quantum number. This quantum number gives an idea regarding the location and energy of an electron with respect to shells or orbits or energy levels. It represents the average size of the electron cloud, that is, the average distance of the electron from the nucleus. According to Bohr, this principal quantum number is nothing but the presence of an electron in the orbit. The principal quantum numbers have the integral values n is equal to 1, 2, 3, 4, and so on. N is equal to 1 represents electron is in the K shell. N is equal to 2 represents electron is in the L shell. 3 represents the M shell, and 4 represents N shell respectively. Higher the value of N, larger the size of the shell or the orbit, and greater the energy associated with the electron. Maximum number of electrons in any shell is given by 2n square. Now, if n is equal to 1, n square, the 2n square becomes 2, n is equal to 2, it becomes 8, and so on. Therefore, K shell is having maximum capacity to accommodate 2 electrons, L shell 8 electrons, M shell 18 electrons, and N shell 32 electrons respectively. According to Bohr, energy of the first orbit is minus 1312 kilojoules per mole, that is maximum stability. This state is called the ground state or stationary state of an electron in an atom. The energy needed to knock out an electron from hydrogen atom is plus 1312 kilojoules per mole. This is called ionization energy. Coming to the second one, azimuthal or subsidiary or orbital or angular quantum number. This quantum number gives an idea regarding the location and energy of an electron with respect to subshells. It also describes the shape of the orbital occupied by the electron and the angular momentum of the electron. For any given value of n, L can have the values 0, 1, 2, dash dash up to n minus 1. So, if L is equal to 0, it refers to S subshell. L is equal to 1 refers to P subshell. L is equal to 2 refers to D subshell. And L is equal to 3 refers to F subshell respectively. The maximum number of electrons in any subshell is given by 2 into bracket 2L plus 1. So from this equation, we come to know if L is equal to 0, it is 2, L is equal to 1, it becomes 6, L is equal to 2 becomes 10, and so on. Therefore, S, P, D and F subshells contain 2, 6, 10 and 14 electrons respectively. The total number of subshells in each shell is equal to its principal quantum number. It means the first shell, that is K shell, contains only one subshell, that is S subshell. The L shell, that is N is equal to 2, contains two subshells S and P. Similarly, the third shell, that is M shell, contains three subshells, that is S, P, D, and N shell contains four subshells S, P, D, and F respectively. The letters S, P, D, and F find origin in the atomic spectra of the alkali metals. They are termed as S refers to sharp, P refers to principal, D refers to diffuse, and F refers to fundamental series. Here I have shown the quantum numbers, the azimuthal quantum numbers. If the azimuthal quantum number is 0, it means S subshell, and that S subshell is spherical in shape. And the P subshell, L is equal to 1, it is dumbbell in shape. D subshell, where L is equal to 2, that is double dumbbell in shape. And L is equal to 3 refers to F subshell, which is having more complicated or complex structure, or triple dumbbell in shape. Coming to the third one, magnetic quantum number. This quantum number gives an idea regarding the location and energy of an electron with respect to orbitals and also the orientation of the orbitals in space. That means it gives the shape of an electron cloud in strong magnetic field. In the absence of electric and magnetic field, these orientations are degenerate, that is, they are identical in energy. The number of orbitals in any subshell is given by the equation 2L plus 1. For a given value of L, M can have the values from minus L to plus L through 0. For L is equal to 0, M is also having a 0 value. That is, s subshell contains only one s orbital. For L is equal to 1, that is p subshell, m is having three values. Those three values are minus 1, 0, plus 1. So, minus 1, 0, plus 1 are given to px, py and pz orbitals. For L is equal to 2, that is the d subshell, the d subshell is having the 5 the m values. Those 5 m values are minus 2, minus 1, 0, plus 1, plus 2. So these numbers are assigned to 5 d orbitals, that is dxy, dyz, dxz, dx square minus y square and dz square orbitals. Similarly, f subshell contains 7 f orbitals which are complicated in structure. The maximum number of orbitals in a shell is n square. First shell contains only one orbital, that is one s orbital. Second shell contains the n is equal to 2. It contains 4 orbitals, that is 2s, 2px, 2py, 2pz. Similarly, third shell contains 9 orbitals and fourth shell contains 16 orbitals respectively. Coming to the fourth quantum number, that is spin quantum number. An electron not only revolves around the nucleus of an atom, but it also revolves around its own axis. This is called spinning of an electron. This spin creates a small magnetic field. Thus, an electron acts like a tiny magnet. An electron can spin either clockwise or anti-clockwise. If an electron spins in clockwise direction, it is represented as plus half or upward direction. If an electron spins in anti-clockwise direction, it is represented as minus half or downward direction. The capacity of each orbital is to accommodate only 2 electrons of opposite spins. It is represented as the upward and downward in a box. The box refers to orbital and the arrows refers to electrons. Suppose let us, before to go with these problems, these quantum numbers, the three quantum numbers, the first, the principal quantum number gives the presence of electron in the orbit. The azimuthal quantum number gives the location of the electron in the suborbit or subshell, and magnetic quantum number gives the location of the electron in the orbital. Orbit comes from Bohr's theory, subshells comes from Bohr-Sommerfield's theory, and orbital comes from wave mechanical model of an atom. And the magnetic quantum number gives the shape of these orbitals, which also comes from wave mechanical model of an atom. Now, I have given a problem. Which sets of quantum numbers are not possible and why? Now, the first one, n is equal to 5. When n is equal to 5, L can have the values up to n minus 1. Therefore, L is equal to 4. That is right. When L is equal to 4, so the m value also will be having, how many values will be there? So, it is the 2L plus 1. So, 2L plus 1 means, so 4 into 2 is 8 plus 1, the 9 values. 9 values from minus 3, minus 2, minus 1, 0, plus 1 plus 2 plus 3. So therefore m is also there in this. So the first one is it is a correct one. The question is which are not possible. So when n is equal to 3, L can also have a 0 value, but when L is equal to 0, M is also equal to 0. But here they have given M is equal to minus 1. So therefore the second is a wrong one. Third, n is equal to 3. So when n is equal to 3, L can have up to n minus 1 values. So therefore, L is equal to 1 is right. When L is equal to 1, M can have the 3 values. So that is 2L plus 1. It means 3 values. So what are those 3 values? Minus 1, 0, plus 1. So M is 2 here it is given. So therefore the C is also a wrong one. Fourth, n is equal to 2. L can also be equal to 2 here it is given. So when n is equal to 2, L cannot be equal to 2 because L values will be n minus 1. So therefore the D is also a wrong one. The fifth, n is equal to 2, L is equal to 1. So it is possible because n minus 1 value. When L is equal to 1, M can have the 3 values minus 1, 0, plus 1. So it is also a correct, which is all the quantum numbers are thus correct. Like this, you go through the others and give the reasons. Assign quantum numbers for the following orbitals. So 5D. 5D means n is equal to 5 because the number itself says it is in the fifth shell. The numbers 5, 4, 3, they are the values of n. D means L is equal to 2. So when L is equal to 2, that is n is equal to 5, L is equal to 2. 4F, n is equal to 4, L is equal to 3. 3S, n is equal to 3, L is equal to 0. 2P, n is equal to 2, L is equal to 1. So like this, so we can write these things. This is a table where I have shown the values. If n is equal to 1, that is a K shell. It contains only one subshell. That value is 0. So when L is equal to 0, M is also equal to 0 because of the equation 2L plus 1. It is having only one value. That value is a 0 value. Okay. So, and it is called the orbital name. In the first, it is called the 1s orbital. When n is equal to 2, it is having the L shell. It is having 6 plus 2, 8 electrons. So in the M shell, we have 18 electrons, and the fourth, it is having 32 electrons. Now, this is another table in the similar fashion, so showing the various electrons and various values of the N, L and M. In this table, so we have the M values. When L is equal to 1, M is having the value minus 1, 0, plus 1. So the value is given here for the 0 as the PZ orbital, the px orbital. So minus 1 is the pz and plus 1 is the py orbital. So the different books have given the notations for the different orbitals. Here it says, so for all the 0 values, they have given the value that is the pz. So therefore it is having 2pz, 3pz, so like this. Now for the d orbitals, when L is equal to 1, M is having totally 5 values. So those 5 values are 0, plus 1, minus 1, plus 2, minus 2. So 0 refers to dxy orbital, plus 1 refers to dyz orbital. So minus 1 refers to dxz orbital. Plus 2 refers to dx square minus y square orbital. Minus 2 refers to dz square orbital. This is another table showing these aspects, the quantum number values. So here I have given the shapes of the orbitals. S orbital is spherical in shape and non-directional. Only one type of S orbital is possible. P orbital is dumbbell in shape and it is having directional property. There are three types of p orbitals, that is px, py and pz. D orbitals are double dumbbell in a shape. They have a directional property and there are 5 types of d orbitals. Those are dxy, dyz, dxz orbitals which lie in between the axes, and dx square minus y square and dz square orbitals which lie on the axis. Of course, the f orbitals are complicated or triple dumbbell in a shape, and they too also have a directional property, and there are 7 types of f orbitals. This is a slide showing the various shapes of the orbitals and their diagrams. S orbital is spherical in shape, and we have px, py, pz orbitals are dumbbell in shape, and the d orbitals, so they have a double dumbbell in shape. And here among the among the 5, 3 are in between the axes and 2 are on the axis. Now, as I have told you, the f orbitals are complicated in structure and there are 7 types of the f orbitals. Here I have shown the shapes of these 7 f orbitals. The shapes are like this and their names are also given. So this is a slide showing the s, p, d and f orbitals in 3-dimensional way. Okay. Thank you. Students, go through these, the quantum numbers which you have already studied in your earlier class. These quantum numbers are just like the notations to show the location of the electron in the atom. So, like to know your house, you must know you belongs to which the place or the name of your town, and that is a shell. So the street name, that becomes the subshell, and your house name, that becomes the third, that is the orbital, like principal quantum number, azimuthal quantum number and the magnetic quantum numbers. And finally, the people they are present in the house, so they become the electrons. So this is how the quantum numbers can be compared with the identification of your house in the, what you can say, the system. So go through these quantum numbers properly. Thank you.